Of course, these systems are big and complicated and they have lots of different parts, but they boil down to three main capabilities we're looking for. The first one we call mobility, which is the ability to drive around, just get around in an environment. The second one is perception, so the ability to look at things with sensors and figure out what that means. And then the final thing, and the holy grail, is manipulation, the ability to reach out, touch, grab, snip. So there's been quite a bit of progress on the perception side of things. Cameras are widely available. They're incredibly powerful sensors. They're very cheap. So we're able to drive around and take pictures. And then coupled with that is this revolution in deep neural networks, which allows us to take camera images and mimic whatever kind of assessment a human could make by looking at that image. And I think a key to success is finding standalone applications for it so that we can take this and make it valuable by itself. But it also enables any machine intelligence that goes beyond that. If you want to pick an apple, you have to look at an apple tree and see where the apple is. Right? Well, my advice to them is to be aggressive about adopting the technologies that are out there. So there are simple versions of robots that you can get right now. So there are robots that drive around and can caddy things around in a field. There are versions of the perception systems that do things like fruit counting and yield estimation available right now. And so my advice to growers is try those things out. Try them out for a couple of reasons. One is that by becoming customers of these new companies, you're investing in this technology, right? The companies need to show that they have customers in order to attract larger investment, and they need the larger investment to develop the products to make them better and serve the role. Another reason that growers should be aggressive about using these things is that, frankly, the people who develop the technologies don't really know exactly how they're going to be used, and never will, because we're not growers. So they need to get into the hands of growers, they need to try them out, and then they'll find where the value is that way. The Canopy Architecture is huge and can make the sensing and automation problem really easy, or can make it impossible. And so the traditional styles of sort of three-dimensional canopies, trees, like those do not lend themselves well to automation, right? They do not lend themselves well to sensing because you can't see the fruit in the trees. They don't lend themselves well to automation because you got to push stuff out of the way to get in there and do any kind of operation. So the trellis systems, the 2D fruiting walls that are highly trained with evenly distributed fruit, those are perfect for automation. So those will be the first systems where these technologies can really have big impact. One of the applications we're looking at is dormant season pruning with robots. And there's a couple reasons this is a really good idea from a development pathway. The first is that because any automation technology that's going to come into an orchard is going to require a really well-structured canopy, it's good to have robots create that structured canopy because you're basically adding an extra job. It has to be done more precisely, so let's have a robot do it. There's another thing that's really good about the dormant season pruning problem, and that's that the dormant season lasts a long time, so there's not as much pressure for the robot to be as fast. We have a longer period of time on which we can make those decisions. So from a development pathway perspective, it's an opportunity to build a robot that may be too slow to do harvesting, but can still add value to an operation.